perpendicular distance from a point to a line. The perpendicular distance D from the point x1, y1 to the line ax plus by plus c equals 0 is given by D equals the modulus, so these lines mean modulus, so we take the positive value, of a multiplied by x1 plus b multiplied by y1 plus c1, all divided by the square root of a squared plus b squared. So we see this is the line ax plus by plus c is equal to 0. This is the point x1, y1, and this is the perpendicular distance. So D stands for the perpendicular distance. So this is the formula we use, and in order to use it we need the point and we need the equation of the line, and this gives us the perpendicular distance from the point to the line. Find the perpendicular distance from the point minus 2, 4 to the line 3x plus y minus 8 is equal to 0. So we label our point x1, y1, and we label our line A, B, and C. So x1 is equal to minus 2, y1 is equal to 4, A is equal to 3, B is equal to 1, because y on its own is really 1y, and C is equal to minus 8. Next we substitute into our perpendicular distance formula. So we swap A for 3, x1 for minus 2, remember these need to be multiplied together, that's why there's brackets, B for 1, y1 for 4, again these need to be multiplied together, C for minus 8, that's all divided by the square root of 3 squared plus 1 squared. This gives us minus 6 plus 4 minus 8, and we get the modulus of that, which means we take the positive value, all over the square root of 9 plus 1, which gives us the modulus of minus 10 all over the square root of 10. The modulus of minus 10 is 10, we just take the positive value, and 10 divided by root 10 is root 10. So the perpendicular distance from the point minus 2, 4 to the line 3x plus y minus 8 is equal to 0 is the square root of 10. Find the slopes of the two lines through the point minus 3, 2, which are at a distance of 2 root 2 from the point minus 6, 1. So it'd be a good idea to draw a sketch of this. So here we have two lines. They intersect at the point minus 3, 2. And they are a distance of 2 root 2 from the point minus 6, 1. So we want to find the slopes of the two lines. We want to find the slope of this line and the slope of this line. So we have a point minus 3, 2, and we need the slopes. So here's a point on both of the lines. Now we need to find the slopes. So the formula for the equation of a straight line is y minus y1 equals m times x minus x1. We're going to sub in minus 3 in place of x1 and 2 in place of y1. So we get y minus 2 equals m times x plus 3. This gives us y minus 2 equals mx plus 3m. And bringing everything over the left hand side, we get mx minus y plus 3m plus 2 is equal to 0. So we want our mx to be positive. Next we label, so our m is going to be the a, minus 1 will be the b, and 3m plus 2 will be the c. And we're going to use our ABC values and sub them into our formula for distance. So subbing into our perpendicular distance formula and using the point minus 6, comma 1 as our x1, y1, we get m times minus 6 minus 1 times 1 plus 3m plus 2. And that's all divided by the square root of m squared plus minus 1 squared. And this is equal to 2 root 2, which was given to us in the question. So we simplify. So m times minus 6 plus 3m gives us minus 3m. Minus 1 times 1 is minus 1, and minus 1 plus 2 is 1. So that's where we get 1 minus 3m from. And on the bottom we have the square root of m squared plus minus 1 squared gives us 1. So we get the square root of m squared plus 1, and again it's equal to 2 root 2. Now we have a surd on the right hand side. We have 2 root 2. So to get rid of that, we're going to square both sides. So squaring the left hand side, 1 minus 3m squared will end up giving us 1 minus 6m plus 9 squared, 9m squared. And the square root of m squared plus 1 will give us m squared plus 1. So basically the squared and the square root just cancel out. And then on the right hand side, 2 root 2 squared gives us 8. So you may want to do this step out as rough work. So on the right hand side you could have done 1 minus 3m multiplied by 1 minus 3m, so cracking open our egg, and you would have ended up with 1 minus 6m plus 9 squared. So we have a fraction on the left hand side, so we want to get rid of that. So on the left hand side we have divided by m squared plus 1. So we're going to multiply both sides by m squared plus 1 to get rid of the fraction. So multiplying the left hand side by m squared plus 1, we just end up bringing down the numerator, which is 1 minus 6m plus 9m squared. And multiplying the right hand side by m squared plus 1, we get 8 times m squared is 8m squared, and 8 times 1 is 8. Then we bring everything over the left hand side, so we get m squared minus 6m minus 7 is equal to 0. Factorising, we get m minus 7 times m plus 1. And solving, we get m is equal to positive 7, or m is equal to minus 1. And remember, m stands for our slope. So the slope of this line is minus 1, and the slope of this line is 7. Distance between parallel lines. To find the distance between two parallel lines, do the following. Step 1. Find one point on one of the lines. Step 2. Find the distance from this point to the other line. So we want to find the distance, labelled here as D, between these two parallel lines. So this line we will just for the moment call ax plus by plus k is equal to 0. And this line we will call ax plus by plus c is equal to 0. And this point is x1, y1. So we want to come up with the distance between these two parallel lines. So notice that whatever is stuck on in front of the x is the same, and whatever is stuck on in front of the y is the same, but our constant is different. This is how we know that the lines are parallel. So remember, parallel lines have the same slope. Points on the same side or opposite sides of a line. 1. Substitute the coordinates of the points into the equation of the line. 2. Two possibilities arise. Same signs, then same side of the line. Opposite signs, then opposite sides of the line. Note, the formula for the perpendicular distance from a point to a line without the modulus bars can also be used with the same results as above. Investigate if the points 101.34 and 58.18 are on the same side of the line 5x minus 13y minus 60 is equal to 0. So the equation of our line is 5x minus 13y minus 60 equals 0. So the first point was 101.34. So the x value is 101 and the y value is 34. So we swap x for 101 with brackets around it and y for 34 with brackets around it. So 5 times 101 minus 13 times 34 minus 60 equals 3. And 3 is positive. So clearly this point is not on the line 5x minus 13y minus 60, because we would have got an answer of 0 if it was on the line. Now we're going to do the same with the other point, 58, 18. So the 58 is the x and the 18 is the y. So we swap x for 58 with a set of brackets. We swap y for 18 with a set of brackets. So we have 5 times 58 minus 13 times 18 minus 60, which gives us minus 4, which is negative. And if, when we subbed in these two values, 58 and 18, if we'd got an answer of 0, it would have told us that the point, 58, 18, was on this line, but it's not. So when we subbed in 101.34, we got a positive answer, 3. When we subbed in 58, 18, we got a negative answer, minus 4. And since one is positive and the other is negative, they are opposite signs. Therefore, the points are on opposite sides of the line. If they had been the same, if they'd both been positive or both been negative, they would have been on the same side of the line. And if they'd both been 0, they would have been on the line.